The Bohr model has its solution and proof from the new emerging quantum theory. So according to Max Planck, some body emits radiation in an order of integral multiples and not in a continuous fashion. Hence, it is possible for the electron not to lose energy continuously. According to him, the energy emitted by the source is proportional to the Planck's constant times the frequency of the source, and this is given by E is equivalent to NHF, wherein N are integral multiples and H is the Planck's constant and F is the frequency. And also, this energy is related to the momentum according to Einstein by the formula P is equivalent to the momentum mb is equivalent to the energy all over c, which is the speed of light. So we can rewrite the formula as momentum p, which is equivalent to mass times velocity, is equivalent to the ratio of the energy to the speed of light, is equivalent to the Planck's constant times n times the frequency of the source all over c. So which can be related to the velocity of the source, in our case the velocity of the electron. We can relate frequency and velocity to the wavelength, so because of the wave theory. So we have momentum p is equivalent to mb is equivalent to the ratio of the energy to the speed of light, which c can be the velocity of our electron. So we'll substitute the corresponding formula for E, which is NHF based from Planck's assumption all over C, and this is equivalent to NH times F all over V. So we can actually derive for the wavelength using the formula for the wave equation, and we have momentum P equals mv is equivalent to NHF all over V is equivalent to N times the Planck's constant all over the wavelength. The wavelength here is actually the de Broglie wavelength. Alright, so de Broglie proposed that matter waves can exist. So the wavelength is the de Broglie wave, which is equivalent to the orbit of the electron. So if the orbit is circular, we have 2 pi r. So we're gonna substitute that in our formula. So the momentum P equals mv is equivalent to n times the Planck's constant divided by the wavelength. And since I've told you that this is just equal to the radius, we're gonna have n times the ratio of the Planck's constant divided by 2 pi r. Solution from the quantum theory. Bohr suggests that the angular momentum of the electron has to be constant. So he starts from the equation P equals or momentum P is equivalent to mv times n times h all over 2 pi r. So he relates the angular momentum L as the product or the cross product of radius vector r times momentum vector p, and it's gonna be mvr. So do not complicate thinking about it. He just cross multiply r to the other side. So he produced the quantity L, which is called the angular momentum. So we have mvr is equivalent to n times h all over 2 pi. And we know that these are just constants. So he have found out that the angular momentum L for the electron in the hydrogen atom is constant. So Bohr went on and tried to find the allowed radius. So here we're going to solve for the allowed radius for the hydrogen atom. Basically, the radius of the electron that is orbiting the hydrogen atom. So let's start with his formula. We have mvr is equivalent to um, nh. All right, so where n is the integer, n is equal to 1, 2, 3, 4, 5, and so on and so forth. So h here is the Planck's constant, and we have a constant 2 pi. So you will see that we can actually divide both sides by mv, and we're gonna find r, or we can divide both sides by mr, and we'll be able to find v. So let's divide both sides by mr, and we're gonna have velocity is equivalent to nh all over 2 pi times mass. All right, so we're going to substitute this formula in the results that we have had earlier from our relationship of the electrostatic force and the um, centripetal force felt by the electron. All right, so because this should be obeyed for the electron to move accordingly based on the predicted characteristic by the quantum and by the classical physics. So we'll use the formula that we have. We have ke squared all over r is equivalent to mv squared. Now we're gonna substitute the velocity, or the expression for the velocity in this one, and then try to square and then try to simplify. So we'll do that. So we substitute v is equivalent to nh all over 2 pi r times m to our equation. So we're gonna have ke squared is equal to ke squared all over r is equal to the mass times the quantity of n h 2 pi r times m raised to the power of 2. So we can actually simplify the expression first by distributing the squared. All right, so we're gonna do some simple algebra here, and it will result to 1 all over 4 pi times the vacuum permittivity of space times e squared all over r. So this is just k. So this constant right here is just k. So we just rewrite it in terms of some few constants. So E here is the basic charge, all right? So fundamental amount of charge or magnitude of charge, which is 1.6 times 10 to the negative 19 coulombs, all right? And square that, and here we have R. So once you simplify this, you're gonna have 1 all over 4 pi times vacuum permittivity times e squared all over r. So we have n squared, all right? So we square that times h squared all over 4 pi squared r squared times m squared. So what we can do right now is to cross multiply so that it will be easy. All right, so and yes, so cross multiply, and once we do that, it will result to 4 pi squared r squared times m squared all over 4 pi times the vacuum permittivity times m times e squared all over r, and this is equivalent to n squared h squared. So basically some terms will cancel out, like 4 pi and the mass, and we're gonna remove some here also, or cancel out some terms here, and it will result to m times pi r times e squared all over the permittivity. All right, so it's equivalent to n squared h squared. All right, so now you can solve for the radius by cross multiplying again. So we multiply that, and what will end up with this formula. All right, and r is actually Oh, it's equal to n squared h squared times the vacuum permittivity all over the mass times pi times the charge square. So here, n is called the principal quantum number that tells us the size of the atom or how far the electron shell from the nucleus of the atom.